Good morning, everyone. My name is Deirdre Denman, and I'm the Marketing Coordinator for EandM. Thank you for attending our webinar today titled How IO-Link is Revolutionizing OEE, Changeover, and Predictive Maintenance. After the webinar this morning, we will be doing a short Q&A. Please type any questions or comments into the Q&A box, the chat box, or email us at webinar@eandm.com. I'd like to introduce your presenter for today, Lily Diaz, IO-Link expert with EandM. And without further ado, I would like to turn it over to Lily to get us started. Good morning, Lily.
Good morning, Deirdre. Thank you so much for having me. So as Deirdre said, I will be presenting on the topic today. And before we get into the topic of IO-Link and overall equipment efficiency, I'm going to quickly just take a couple of moments to introduce EandM for those of you that might be new to one of our webinars. So EandM is the West Coast leader in automation. We have our home office based out of beautiful Healdsburg, California, 2 sales offices, one in Northern California, one in Southern California, and we've just expanded to the Pacific Northwest late last year. So we do cover the whole West Coast currently. We do have a huge amount of stock that ships out to all these areas. All that stock is in our Healdsburg office. And generally speaking, it's about 2 days as we are just going up the West Coast. We do have over 160,000 parts stocked in Healdsburg for your convenience, and about 1,400 of those get shipped out every day to all of you guys. We do have a wonderful team for our inside sales group. You can see their bright, shining faces right here. These are the people that you probably interact with the most. They are the fastest quote providers in the West. Everything is done within the hour, and if not within the hour, within the day. So we're extremely proud of them. They do a wonderful job, and they help us help you. We also have a wonderful group of gentlemen who work in our tech support. All of these guys are based out of California, but are available to the whole West Coast. There is no voicemail here. 9 times out of 10 when you call, or actually most likely 10 times out of 10 when you call, you're going to get one of these gentlemen on the phone with you. They help support us and give you answers and accurate information to help you get your project up and running or to troubleshoot an existing project. They also give me a call if you guys need a little bit more help, or if you guys need someone on site and I need to be there for you. EandM does also provide some workshops and trainings to our customers. This year we're offering a total of 32 trainings, in-depth training courses. Those are 4-day courses. You would come to one of our offices and do 4 days of a deep dive into one of our products. We also offer free workshops. Those tend to be half-day courses. There's about 15 of those scheduled right now. And if you are interested in taking any classes with us, please go to our website, EandM.com. We also are extending our roadshow to the Pacific Northwest this May. Many of our customers in California have attended one of our roadshow events in the past. If you are out of the Pacific Northwest and are interested in our roadshow or learning more about our products, you can go and look and register once again on our website, EandM.com. So now let's get into the reason why you guys came, the meat of our presentation, IO-Link and how it's revolutionizing overall equipment efficiency. Specifically, we're going to be talking about changeover and predictive maintenance. So many of you out there are probably experiencing some changeover pains. unless you have a fully automated system. Many of our customers are using a semi-automated or a system where you do have a human element to your changeover. So there's kind of two areas where we find most of our customers struggle. One of those areas is finding the right change part. That could be as simple as just changing a rail out, or it could be more extensive, a mold, a tube, something along those lines. And sometimes all those parts look really, really similar. And then once you've got the part selected, getting the part aligned correctly, this presentation will highlight mostly linear change. So we're focusing on getting the part aligned correctly and reliably every single time. What you're probably doing right now to get these parts into the system and then align them correctly is just by visual inspection. A lot of people color code their parts or write on them the SKU number or the size of the box for the change part. So you're relying on your operator to select the correct part. Once it's got the part selected, we also see customers using either measuring tapes that they've stuck down to their machine, or maybe even like different colored paint pin marks to measure where the adjustment for that specific process is going to need to go. Now, like I said, there is human error in this, so it's very unreliable as far as a precise adjustment. So due to this imprecise adjustment or confusion of change part, you're most likely losing material. I know a lot of times when you start up a machine, after you've done a change, there is naturally some loss in the material lost, incorrectly made, boxes, packaging, anything like that. But then you have to send someone out to sit there and adjust it, tweak it, make it so that it does, start creating correct product or correct packaging. And so you're essentially wasting someone's time, and you're losing some of the product that you guys are doing. Both of those things together equal a loss in profit, as well as a reduced overall efficiency of your machine. So we're working with IOLink to help you guys solve these problems. IOLink is going to help you make the changeover just go faster, reduce the time it takes for you to do the changeover, because it's going to help you be more accurate with your initial positioning, so no more tweaking the machine once you've got it set up. That also means that you're going to be selecting the correct change part every time. It's going to help to reduce the waste that you guys are producing upon startup and any other quality concern products. You can use some of your existing sensors on your machines. We only really need to swap the ones that are causing the bottleneck or that are monitoring a lot of the adjustment. And with a little bit of integration of existing HMIs or stack lights, it can become very intuitive for the operator. So before we get into changeover and everything else, I really want to highlight IOLink because I get a lot of questions about it. It is a little bit of a new concept, so I kind of just want to go through it briefly before we get into the application areas. So IOLink is a universal protocol that is smart and easy to set up. It essentially simplifies your existing control architecture and provides visibility down to the sensor level. And it really truly is the backbone of many smart factories that are starting, many factories that are wanting to go smart. IOTT or Industry 4.0 seems to be the buzzwords surrounding the smart factory integration. Now, IOLink is capable of a star topology, much like any kind of distributed I/O system. So you would just simply connect your network of choice. You can see here on the right-hand side, there's a network at the very top connecting to that master block. And that's all the shielded cable you'd ever need. Everything else is just a standard prox. And then from there, you extend the master block out to either smart sensors or the sensors you have pre-existing. If 8 points of IO-Link or 16 points of discrete are not quite enough for you, we do have an option to extend to a hub. Now, you can put one hub on each IO-Link port, and so you get kind of 8 times the amount of data that you would normally get. And then from there, if you did need extra, many of the blocks that are available today are expandable to one more layer. So you can kind of get a lot of digital information back to your network just over one little cable. Like I mentioned, you can use it with your existing PLC or existing network and your existing sensors. So it's a really easy way to retrofit a machine or upgrade a project. So IO-Link sensors, this is a little bit more on the smart side of things as far as the smart sensor goes. They can communicate 3 different kinds of data. So that's your process, parameter, and event data. Essentially, they kind of work as their own safety net. They can tell you a lot more information than just, you know, I am high, low, 0 to 10, 4 to 20. And if you are getting, if you are using a IO-Link analog sensor, you can get those data points that you're getting back in an engineering unit. So either a distance, you know, a pressure, or even a temperature. So it gives you a little bit more smarts from the sensor back to your system, so you don't have to do necessarily as much math in your PLC. So again, IO-Link is a little bit more of a point-to-point, peer-to-peer communication. That means that we're using it kind of like USB, and I'll show you that in a second here. But as I mentioned before, we are moving away from using any kind of shielded cable. We're rolling with just a standard 4-pin prox cable, and that's reducing the cost a lot. Everything is also quick connect, so there's no more field terminations into a cabinet or into a card. So it's simplifying and making everything a little bit more plug and play. Now, you can go 20 meters from the master to a sensor, but let's say you need to go a little bit farther. If you're using a hub, you can go 20 meters from the master to the hub, and then from the hub to the sensor, or to another hub, as you can kind of see in this illustration to the right. Now, this is where we get into how it's like USB. So IO-Link is very universal. It is vendor neutral, and it's an open ICE standard, or IEC standard, excuse me. And it's designed to act very much like USB for your laptop or your computer. You know, no matter what brand of laptop you might have and what brand of wireless mouse you have, as soon as you plug in that USB, the driver is downloaded and they communicate. Same idea with IO-Link. Right here on the right, you can see a whole bunch of the different brands that make any number of IO-Link sensors. Valve is a big one. They have a very large portfolio, but there are some things that they don't make. A good example would be Valve. So if you did want an IO-Link connected Valve, there's one out there that is going to work no matter what with the system. IO-Link is universal no matter what brand is making it. IO-Link is also universal in a different way. It works with your existing network architecture. So no matter what network you're using, if it's Ethernet, if it's Profinet, if it's EtherCAT even, there is a IO-Link master out there that will talk to it. So you don't need to worry about your existing network. We don't need to add any new drops. It's also controller agnostic. So that means that we can talk to pretty much any PLC out there. The ones I work with most are, of course, Siemens and Allen Bradley, but we do have options to connect to other controllers. And if you do happen to have a robot in your facility and want to quick connect it and add any of the features, other features that IO-Link has to it, it is robot agnostic as well. IO-Link is a relatively intuitive way to get your machines and your systems up and going. It does eliminate any need for manual configuration. That goes as far back as field terminating sensors to a I/O card, similar to that picture right there. It also, using a smart sensor, eliminates need to reconfigure a sensor once you've replaced one. So let's say you break a photo eye and you need to replace it with a new one. As long as you plug in the exact same part number of that IO-Link sensor into the master block, it pushes the settings for that sensor to it. So that eliminates any errors when you're setting up a new device, but it can also help you find and replace sensors that have gone bad or other things that have malfunctioned. Unlike before, where you might have to go get a multimeter and test all of your points of I/O in your cabinet, the master block actually has some LEDs on the front of it. Those LEDs will turn bright red when something has malfunctioned on that specific port, and you can trace it out through hubs to find the sensor in particular that's not functioning. So you're not spending a lot of time with your head in the cabinet trying to troubleshoot. You're actually finding the sensor relatively quickly to replace it and get your machine back up and running. And like I mentioned before, IO-Link simplifies your controls architecture. So it's one standard interface from your network down. And as I mentioned, we're using the same standard cable across the board to integrate everything. So that's your discrete, your analog, and your smart devices. And then there are some specialty devices, depending upon the manufacturer of the IO-Link device itself. They will vary. Balluff has a lot of RFID over IO-Link, which is a big part for us with change part selection, but they also do offer vision as an application area over RFID or over IO-Link. So here you can kind of see all those red lines there are the standard interface, and then just your communication to your PLC out the top. And then this is a bit more of a visual way to see how IO-Link simplifies your controls architecture. So traditionally, there's kind of 3 layers of your architecture here. So there's an information layer, and then the actual controls layer, and then all of your devices, your sensors, whatever hanging off of that. So you can kind of see that that prox that we're indicating there is most likely hardwired to the PLC, and it's got one line of communication into the system. So this is a little bit more the old school way of doing it. And then here we've got the IO-Link method. So this here is a very flat view. You can see that we've eliminated almost 2 layers of your architecture here. So everything is connecting directly up into your software, your SCADA, into your PLCs, and all of those sensors are communicating almost pretty much directly with that network as well. Now, you see that database cloud in the upper right-hand corner is actually pointing at a pressure sensor right there. That's just letting us know that there is the option for us to view the information coming from these sensors online. Balluff offers a web browser for your master blocks, so you can go in and monitor some of the information from your sensors live online. Is another great way to help troubleshoot and just give you better feedback for these sensors. So now that we've kind of talked a little bit about IO-Link, I'm going to just go through a couple of definitions really quickly to make sure we all are on the same page as to what overall equipment efficiency and changeover are. So the general definition of overall equipment efficiency, or OEE, is the percentage of time that the manufacturing on your machine is truly productive. And there's kind of 3 areas that make up overall equipment efficiency. The first is availability loss. So that's anytime the machine is unavailable to perform its duties. So whether that's a planned or unplanned downtime, any kind of failure or anything like that. And the second is performance loss. So that's either small stops, maybe parts of your machines aren't getting, individual cells aren't getting parts fast enough and they're stopping, or maybe your machine isn't running at optimum speed. So you're just not making things as quickly as you could. And the last area is quality loss. This goes back again to the startup rejects and quality control of, overall equipment efficiency and your changeover process. So we're trying our best to reduce all of these areas and just keep our machines as efficient as possible. Now, we're going to define changeover for this presentation just to make sure, because we are talking about mostly format change and linear format change, along with a little bit of change part replacement. So format change is changing out parts on a machine to make sure it's able to run a different size of a product or a new product. So there are some semi-automatic and automatic systems. Those actually tell you exactly when you're in the right position. That's kind of what we're aiming for. We're hoping IOLink can help you get to more of a semi-automatic condition. So guided format change is what we're really going to be focusing on as far as the changing goes. So that's, moving something in and out or adjusting the size of something. So it can be any number of things. Generally, they involve some kind of hand crank or physical movement by a human. There's also the side of this that is change part. So that's making sure that you've selected the correct, fixture, mold, any kind of physical thing that you have to change on your machine to make sure you're going to be able to build or make the next product. So right here, we've just got an IOLink master that's connecting to a linear measurement sensor. So it's just making sure that, you're moving the device as far as you need it to be and tracking it. So that moves into, kind of our changeover for linear positioning. So like I mentioned before, we're normally doing these changes when you're changing the size of a bag, a carton, any kind of container, even a bottle. And so you want to verify the position of the rail or whatever it might be that you're physically moving. And you want to make sure you get it right every time and that your team can do it as fast as possible to eliminate downtime. And then you don't want to have to go back and change it again. So Ballot does offer a wide variety of linear distance measurement options, all of which are available over IOLink. Now this will give you a very precise measurement for your changeover. It can tell you exactly where you are along the stroke or the length of the sensing of the device. Here we actually have a couple of different versions that I really like. That third one down is a linear transducer, great for areas where you're turning a crank or something and you can mount a magnet on a rail that's moving. There's also a optical sensor, so a photo eye there. That's that fourth one down. And then the very last one is a magnetic linear encoder. Works similarly to that transducer and could potentially be better if you have parts that actually swap out and move at the same time. So there's lots of ways to kind of skin this cat as far as, what kind of sensor you use, but using it over IOLink will help you accurately measure how far you've moved your change and then if it is in the right spot. Now, as far as doing a change part, again, you're probably doing this when you're changing the size of something, and it can be anything from a mold to, just a fixture that you're changing out. We find a lot of people use RFID to great success. You can embed the little RFID tag right into the change part and either present it to a read-write head before the operator puts the change part in after they've selected the new recipe. And then that way you can make sure that you're getting the right part in there and you're not going to be making deformed bags or anything like that. So RFID over IOLink just ties into the system and makes it very easy. RFID over IOLink is also really easy to set up. So again, IO-Link for both the linear positioning and the changeover parts is helping you reduce overall changeover time. That's selecting the right part, making sure it's adjusted accurately every time so you don't have to tweak it anymore. You can use existing sensors. If you have a linear position sensor that maybe is an analog sensor and it's just not helping you, we can integrate that into the system, making it more intuitive for the operator by using an HMI or other human-machine interfaces. You're also going to reduce that waste. You're not going to have to tweak it or, lose any of that startup yield that you might normally. So lastly, we're going to quickly touch on predictive maintenance and how IO-Link can help, mitigate some of your predictive maintenance. So we all know that a lot of us are kind of in the mode of learning what predictive maintenance is and getting that metric built into our maintenance, system. And so a lot of people want to, with the predictive maintenance, make sure that they are preventing any unplanned downtime by predicting when a failure is going to happen. So that overall is going to help increase your overall equipment efficiency. So you're not going to have random equipment failures or any of those stops or slow cycles. You're going to get rid of any of those bottlenecks. And from what we found, only 18% of machine failure is captured by preventative maintenance. So you're better off doing a little bit more predictive maintenance on your machines. So IO-Link can aid with preventative maintenance by giving you those smart sensors. Smart sensors overall give you more information back. Depending upon the sensor, it can give you more diagnostic events. So we'll get into that in just a second. But let's just say you want to count, sort things. A lot of that comes back through the IO-Link. You can get a little bit more information, let's say from an RFID tag, will let you know how many times you've used that press or used that die. You can also get parameter data back. Photo eyes will, their gain will change depending upon how dirty they are. So they'll tell you, hey, I'm dirty, come clean me. And then depending upon the sensor and the manufacturer, they might also give you some other information back. So the temperature of the sensor, if it's vibrating, and sometimes it will even tell you if there's a current or voltage issue within the sensor. So you can monitor that through the cloud over the web browser, or you can ask the master and the sensor collectively to push stuff to the PLC to give you a warning so that you can go out and clean the device or swap it out for a new one. So really help to reduce any planned stops or any unwanted production rejects. So overall, IO-Link increases your OEE. So it's enabling a lot of the smart factory concepts, that you've heard about in today's world. So it's bringing you the intelligent devices, those smart sensors that are giving you more information, more accurate information, and all of those enhanced diagnostics. So temperature, vibration, all that fun stuff. It also utilizes your existing devices and your existing network, so you don't have to make a big change to do a simple retrofit. So this is just an application example. We have a customer in Northern California who's looking into putting IO-Link for actually a linear changeover on one of their carton erectors. They have looked at some other solutions that were a little bit more automation than they were willing to do. So they're really excited to look at IO-Link because they're going to be able to keep their existing network, just reducing their analog sensors and not make as many changes to their PLC program as the other more automated solutions were suggesting. So once again, IO-Link is helping you increase your OEE and get your changeover stuff settled and help you with predictive maintenance, all by reducing your unplanned downtime, helping you pinpoint bottlenecks, reducing any kind of tweaking you need to do. It's also helping you, make sure that you've got all your sensors aligned correctly, et cetera, and just reducing any kind of bad settings you might have on your setup. So that's been how IO-Link helps increase your overall equipment efficiency, specifically with changeover and predictive maintenance. Thank you so much for your attention. I'm willing to take any questions you guys may have.
Perfect. Thanks, Lily. Yeah, so we will open it up for questions. Please type any questions into our Q&A box, chat box, or email us at webinar@eandm.com. Lily, we did have several questions come in during the webinar that we'll address first. The first question is, how do I program IO-Link?
That's a great question. So IO-Link, generally speaking, doesn't come with any additional software you would need. The ballast components all come with function blocks or add-on instructions, depending upon the PLC you're using. And you would simply integrate them into your ladder logic like you would normally programming. So all of the devices, that's the master and the smart sensors, would have some kind of function block that you would integrate into an existing program. And if you did need any help with that, I'm always available to come out and help you.
Thanks. And then another question, are there any added files for identifying sensors from the different vendors?
Of course. A lot of times, along with the function block, many manufacturers will give you an add-on instruction or an add-on instruction plus an IODD file. The IODD file is essentially just the rest of the information about the sensor, the part number, things like that. And it can also provide a little bit of extra information to the PLC and to the master block to let it know how it's going to perform and what it's going to do. So it's a little bit easier to troubleshoot as well when you're looking at the web browser.
Okay, another one that came in is, are IO-Link master blocks able to use analog sensors?
The master block itself is not able to have an analog sensor directly plugged into it unless that particular analog sensor does also communicate over IO-Link. If you are wanting to use a traditional analog sensor, we do have analog input hubs. Those have 8 ports. But if you wanted to use some output data, we do have single channel output for analog signals if needed. So yes, you can use analog with IO-Link, just not plugged directly into an IO-Link master block from Ballast.
Okay, and then how would we monitor the sensors via the cloud?
A lot of the monitoring of the sensors via the cloud would just be through the web browser provided by Ballast. So you could log into the IP address of the specific master block you're looking at. From there, you can click on each individual port and see what's plugged in. Now, depending upon what kind of sensor you have plugged into the master device, it will change the amount of information you're able to see. Of course, if you have an IO-Link sensor plugged in, you get a lot more information. You can actually set some set points and do some tweaking of the sensor from the web browser if it is a smart IO-Link sensor. If you've got a discrete input or output going in there, you can see values change and tell generally what it's doing, but you can't necessarily adjust it or tweak with it at all. You can't communicate with it as much. Same thing goes for a hub. If you're communicating to a hub, you can't necessarily see all of the sensors that are connected to it because those would all be discrete or analog inputs, traditional analog inputs there. But it would help you monitor the data coming through the hub and just make sure everything's working fine.
Okay. Thank you, Lily. It looks like we don't have any other questions that came in. That concludes our webinar for this morning. Thank you again, Lily. And If you would like to review any portion of this webinar, a recording will be available on our website at eandm.com this afternoon. And again, you can find more information about our future webinars on our website, and have a great weekend.